here's where it really gets tricky. We also know that anytime you make a part, it never comes out exactly what you were told it to do. So if I 3D print a part and say I want it to be 0.50 diameter, it might be 0.502 or 0.498 or 0.550. Okay? And different designs need better control than other designs. Some designs you really don't care. As long as it goes in there and it's close. Some of them need to be like so close that you have to tap it with a mallet to get it in. And that's called the fit. So not only might I have that transfer shaft of a certain dimension, I might need to control the fit. And so on any one job, to make sure that your dimensions are right, you have to check that fit against all possible combinations of the part you've got and the part it's going into. And that's called a tolerance review. Okay, and the tolerance is the deviation. How far from perfect or nominal are you allowed to go? Okay, so now let me come up and I'm going to pull up another drawing. I'll pull up a gear hub, pull up the pinion. So what you can see on here is this gear says, I'm going to try to make that hex hole, hex slot, 0.541 across the slot. But I'll accept it anywhere up to 20 thousandths bigger. So 0.541 up to 0.561. Well, as we know from numbers, that gives me an infinite number of possibilities. So how am I going to check all the possibilities? Okay. Well, we take two conditions. One is called maximum material condition, and the other is least material condition. So let me talk about those on this one. On this part, this gear would have more material in it when this hole is what? Bigger or smaller? This gear would use more material if this hole was which? Bigger or smaller? Somebody just go ahead and pipe in with that. Okay, just unmute yourself and yeah, Alejandro.
Hey, sorry, can you repeat that? I was writing something down.
Okay, so here I've got a gear and I'm going to put a hole in it. Would this gear use up more material if the hole was bigger or smaller?
It will use up less material, right? Because they would have to make it bigger.
Well, if I put a bigger hole in it, it would use less material, right?
Yeah.
And if I made a hole smaller, it would use more material. And you can
Hmm.
think about that. If my hole was size 0, this gear would use more material than if my hole was huge. So on a hole, maximum material condition. When does this gear use up the maximum amount of material is when the hole is the smallest. So 0.541, it's the minus tolerance on a hole. Now let's look at the shaft. Is this shaft going to take more material if the shaft is smaller or if it's bigger? It will be if it's bigger, of course. If I had a 4-inch shaft, it would obviously use more material than an 1/8-inch shaft. So those are two things to really keep in mind. Okay, I'm going to write that down here, right here. Hole. MMC is smallest diameter. Hole. LMC is largest diameter. I'm going to make those a little bit smaller so I can fit that in for the other one too. And hopefully that all made sense then. And so for a shaft, it's just the opposite. It's the largest diameter. And for a shaft, LMC is the smallest diameter. So that's how you get these numbers to do on the design review. Okay, that's where those numbers came from. So that's LMC and MMC for shafts and holes.